Today we are looking at 11.2, which is called immunity. So last class we had talked about the first two lines of defense. The first line of defense was the physical barriers like your skin, and then the second line of defense was that non-specific response, such as inflammation, swelling, redness, that sort of thing. So today we're going to look at specific responses to a specific pathogen. The first example we are looking at is chickenpox. So few people get this disease now, since there is now a vaccination for it. However, even if you haven't been vaccinated, if you already had the disease, you're unlikely to get it again. And the reason for that is because the body builds up immunity or resistance to chickenpox. So if you were exposed to the virus again, your immune system is able to recognize it and resist it. There's something called antigens. These are structures that are attached to all cells. They're proteins, and they help the body's immune system identify pathogens. So anything foreign entering the body are going to have these foreign antigens. So the body recognizes substances called antigens that are not part of itself. And these antigens are specifically shaped structures that are attached to pathogens, and all living tissues like viruses, bacteria, and fungi, they all contain antigens, even pollen, transfused blood, transplanted organs, and cancer cells. They all contain these proteins called antigens. So how does the immune system respond to the antigens it encounters? It's the white blood cells that will respond. The white blood cells, they make and release these Y-shaped protein compounds called antibodies. And these antibodies are now going to work to bind to specific antigens, which will make it easier then for white blood cells to come and destroy them. So when you first contacted chickenpox, the virus, your body doesn't have the antibodies against the chickenpox antigen, but the immune system will start producing the antibodies. Then your body now will have the antibodies to that pathogen, such as the chickenpox virus. And then if you get exposed to it next time, your immune system is able to recognize it, and it'll destroy the antigen whenever it shows up again. All right, and that's why you're considered to be immune to the disease. So here's just an example showing, here we have the invading pathogens, 1 and 2. So let's say there are 2 bacteria cells, and they've invaded the body. And notice sticking out of these, we have these orange colored shapes here. Those are the antigens sticking out of the bacteria cells. So those are the antigen markers. And therefore, the body, the white blood cells, will start producing these antibodies. They look like a Y-shaped structure. And on the tips here and here, they have the shape that can attach to that antigen marker. So each antibody has a shape that matches a specific antigen. So this means that an antibody that's produced against a cold virus, it's not going to fit with, for example, an HIV antigen. All right, so looking here, antibody type A attaches one type of antigen with a complementary shape. It's like a lock and key fit. All right, so for example, a flu antibody would combine with the flu antigens. Looking at antibody type B, it's got a different shape or a different structure here at the ends, and it doesn't match with the invading pathogens. It doesn't match with the antigen marker. So antibody type B, it does not combine with this antigen because their shapes do not match. All right, so this the antibody markers here and here are different from those found on the antigen. All right, so antibody type B will not be able to attach to this pathogen's antigen markers. During organ transplants, it's a similar response because these organs are coming from donors. And so the immune system produces antibodies against the antigens in transplanted organs. And then these patients are given anti-rejection drugs to prevent their bodies from rejecting the transplant. But the downside to this is that the medication shuts down the immune system and it makes these patients less resistant to pathogens. All right, this immune system on alert, this figure here is showing how the immune system responds when a pathogen gets past the first two defenses or when it assists an inflammatory response to a pathogen entering the body. So at number 1 here, these green structures here are the bacteria. So bacteria have entered the body. An inflammatory response is going to occur. The macrophages are going to surround and destroy some of that bacteria. So that's what we can see here. This is a macrophage and it's engulfed that bacteria inside of it. Now, the antigens that was found on the bacteria are going to stick out from the macrophages that engulf the bacteria. So we can see them sticking out here now, out of the macrophage. Those are those antigen markers. Next, white blood cells, they're called helper T cells, shown here. They're going to identify the antigens on the macrophage, and then white blood cells called B cells will start making and releasing antibodies. All right, so here's the B cell. It's going to start making the antibodies. The antibodies that are produced by the B cells, they're going to attach to the antigens and destroy them. All right, so that's what we can see happening here. The B cell produced the antibodies. The antibodies now have attached to the cell and to the cell's antigens and will start destroying it. Next is the memory cell. So the B cells will also produce memory cells, and these memory cells are going to store information about the antigen of the invader and then making it easier to destroy if those pathogens were to enter again. Okay, there's two types of immunity. There's inherited immunity. This is resistance that organisms have to most diseases, and it's passed on genetically. So you're born with a certain amount of immunity. And then there's acquired immunity. This is the body's immunity to pathogens developed throughout life by natural exposure or vaccination. So from birth on, you build acquired immunity. And it's divided into two types according to how you get it. So acquired immunity is divided into two groups called active immunity and passive immunity. So active immunity is when your body develops active immunity by making antibodies against diseases to which you have been exposed. This is the type of immunity you would have developed against chickenpox. So this is the body's process of developing antibodies against certain diseases. Passive immunity, you acquire passive immunity from antibodies produced in another animal and then it's put in your body. This is the kind of immunity you might get against, for example, tetanus, when you get a tetanus vaccination. So antibodies are introduced into the body to create immunity, right? So that's the difference between active and passive. All right, so just looking at this flow chart here. So immunity is the ability to resist disease. There's two types. Inherited immunity, that's what's present in the body from birth. It lasts over a lifetime. And then there's acquired immunity. That's the what you acquire over your lifetime. All right, it develops in the body during the lifetime. There's two types of acquired immunity. Active immunity, that's when the body will make its own antibodies. It's usually permanent. Passive immunity, antibodies are introduced to the body. It does not last as long as active immunity. All right, and then both active immunity and passive immunity can be naturally acquired or artificially acquired. Naturally acquired and artificially acquired. So looking here at these examples, the first one, a naturally acquired active immunity. For example, strawberry tongue is also called, which is a symptom of scarlet fever. And once you've had scarlet fever, you are unlikely to get it again because your body builds immunity against the disease. So that's a naturally acquired active immunity. Here is an artificially acquired active immunity. This is the hepatitis B vaccine, which works against hepatitis in teens. It provides artificial immunity. The hepatitis virus is cultivated by infecting yeast cells. Here is an example of naturally acquired passive immunity, showing babies. As long as babies continue to breastfeed, they are immune to many of the same diseases as their mother. And then an example of artificially acquired passive immunity, showing here small amounts of snake venom are injected into animals like cows or whole horses to create antibodies. The antibodies are called antitoxins. Then that antitoxin is removed from the animal's blood and is used to provide immunity in people who are bitten by that type of poisonous snake. All right, and lastly, we're just looking at blood transfusions, and there's 4 blood types. There's type A, type B, type AB, and type O. So it's important that doctors check patients' blood type before giving a transfusion, because the blood type of the transfusion, it has to match the blood type of the person who gets it. Blood types must match because there are 2 kinds of antigens on the red blood cells of humans, and there's 2 kinds of antibodies in the plasma. If the blood types don't match, the antigens will react with the antibodies, and it'll cause the blood cells to clump together, and those clumps of blood cells can then lead to heart attacks and strokes. All right, so we'll stop here for 11.2. These are the questions for page 201, numbers 1 to 3. 11.3 is called immunization. So the body can develop immunity either by getting an injection of a vaccine or an injection of an antitoxin. So a vaccine, it consists of a weakened or dead disease pathogens. Once a vaccination or immunization is inside your body will begin to produce antibodies against those antigens in the vaccine. And the disease is weaker than usual because of the weakened or dead pathogens. As a result, you usually get few or no symptoms. And then after your body produces antibodies, you will have lasting protection against the real disease. An antitoxin, these are, for example, the injections for tetanus and diphtheria. They contain antitoxins which are drawn from animal blood. And these antitoxins, they neutralize the effect of toxins, and they act faster than vaccines. So here we're just looking at some preventable diseases that most Canadians are immunized against. Just remember that you're born with all of your mother's antibodies, and these antibodies lasted a short time, longer if you were breastfed. So childhood vaccinations allow you to continue having the benefit of this immunity. So for example, diphtheria is one preventable disease. Effects include infection in the nose and throat. It'll make breathing difficult. It includes skin infections, rapid pulse, heart failure, paralysis, and then it can lead to death. Measles is another preventable disease. Symptoms include red rash, high fever, cough, sore throat, ear infections, and pneumonia. Mumps, this is when the salivary glands get swollen and it's very painful. Fever and headache. Polio, Fever, headache, stiff neck and back, muscle weakness can lead to often a permanent paralysis and then death. Rubella, mild fever, rash, swelling of the neck. It's very dangerous during early pregnancy. It can cause miscarriages and handicaps. And tetanus, muscle spasms, difficulties breathing, it can lead to death. And the whooping cough, severe coughing, difficulties breathing, pneumonia, and it can lead to brain damage and death. All right, so these are the ones that Canadians are immunized against when we get our vaccinations. So why get the immunization shots? Because they prevent more problems. They prevent more problems than they create. They've reduced the incidence of communicable diseases and the number of deaths from them. Worldwide immunization, for example, against smallpox has actually eliminated that disease. And recently, some countries have stopped or limited immunization programs. And what we're seeing now is that there's an increase in diseases like polio that were almost disappeared. All right, in 1796, a British doctor called Edward Jenner gave the first ever vaccination for smallpox. And what he had noticed was that dairy farm women who suffered from cowpox, it's a milder disease that affects cattle, they were immune to smallpox. So we'll watch this quick video here. All right, so some people do not get immunized for personal or medical reasons. And one such reason could be that some people react to certain immunizations. And such reactions often occur in people whose immune systems have been weakened by a disease, such as asthma or by severe allergies. And in such people, the whooping cough vaccine can occasionally cause reactions such as high fevers or seizures. This is just showing the polio virus. This is showing a cell that's infected by the polio virus. And there is no cure for polio. In the 1950s, Jonas Salk introduced a vaccine to prevent polio. They found a way to manufacture enough polio virus to make vaccines. And they won the 1954 Nobel Prize for that discovery. Next, we're just going to talk about allergies. So allergies, they develop when the immune system overreacts and becomes sensitive to substances such as pollen, dust, or mold. And the immune system will then treat the substance as though it's a pathogen, and it's going to start building antibodies against it. And these antibodies result in a variety of symptoms, such as mild reactions like runny nose, itchy or watery eyes, and severe symptoms such as breathing difficulties, and it can lead or build to extreme allergic reactions that can cause death, so such as anaphylaxis. Scratch tests can be done to identify allergens. So basically, the skin is scratched in certain areas, and then drops of antigen are absorbed under the scratched skin. Allergic reactions will produce redness, swelling, and itching along that scratch. People who suffer from allergies sometimes get immunotherapy, which involves injections of weakened allergens, and then regular injections will build the number of antibodies against the allergen. Rabies is it's a virus, and it's from the bite of infected animals such as dogs and wild animals, and it is nearly always fatal if left untreated, and the treatment requires a series of injections of antibodies and vaccines. And there's still continuous research to develop an improved vaccine for rabies. All right, and then that's where we'll stop for 11.3. The check your understanding questions are on page 203, numbers 1 to 4.